Hi everyone, welcome to this new video lecture of fluid mechanics. In this lecture, we'll discuss the concept of hydrostatic forces on surfaces. So the concept of hydrostatic force is actually defined as the force exerted by a fluid, at rest condition on submerged surfaces. Okay. So when the fluid will be in the rest condition, so in that time only we can consider this hydrostatic forces. Okay, and these hydrostatic forces application are having in different areas, such as when we are going to construct dams, then we need to consider this concept. And similarly, where we are going to construct a big tank, what tank is there, and any pipeline construction also, big pipeline construction which will be there. In that time also we need to consider this concept of hydrostatic force. And in the area of medical field also we can apply this concept. Suppose the blood flows in the in our body, and what about the blood pressure in the blood which is flowing in the body, that one. So these are the concepts are going to use in the hydrostatic forces, and this hydrostatic force actually applying in different areas or different surfaces, we can say. So similarly, it is categorized into or it is divided into four types. So first one is the vertical plane. You can say the vertical plane surface submerged in liquid. Similarly, this is about vertical plane. Similarly, next horizontal plane is there. Okay, horizontal plane surface submerged in liquid. Similarly, next is inclined one. One is vertical, next is inclined, and next is horizontal, and another one is there, and that is curved plane. These are the different types of plane surface, okay, which is submerged in liquid. Okay, now what we are going to identify in this concept. So this is the first category we'll discuss. So let's consider the first one. So first one is here a vertical plane. Okay, the vertical plane surface submerged in liquid. This is the first category, vertical plane surface submerged in liquid. So here we are going to calculate in this concept the total pressure. First one is the total pressure. Okay, and the total pressure, what is the pressure exerted by this, and the center of pressure. Okay, or you can say H star. So total pressure, we are going to calculate the value of F, and the center of pressure, so that means the position of that from this free surface, how much is there we need to identify. So two things we are going to calculate from this. Okay, so the vertical plane surface submerged in liquid, let's consider a object, okay, which is situated inside the liquid, and this shape of this surface will be this object will be arbitrary in shape. Okay, and which is located some distance from this free surface. So this is the free surface of the liquid, and here you can see these are the some water particles or water lines are there, and this object, what we have considered, a small strip we have considered here, a small strip area, that width of this is dh. Okay, so what are the things is there? Now if you see from this point to this point, this total, if you see from A point to B point, what we have taken here, and in that the width of this is B. So B is the width of the object, and H, you can say, that is the distance. Okay, distance of this small strip from the free surface. H is the distance from the free surface to the strip, and next is H bar. H bar, actually you need to remember, this is the distance from the free surface to the center of gravity G point here. Okay, now, and H star is the next one is the H star. H star is the distance from the free surface to the center of pressure. Okay, these are the points we need to remember. And G is the, we know that center of gravity of the plane surface. This surface what it is given here, the center of gravity is G point. Okay, so let calculate the first one. These are the notations are there. So let calculate the first one, the total pressure. Okay, the total pressure actually indicated by F. The total pressure indicated by F. Okay, now we know that the pressure on the strip, this is the strip what we have taken. Let's change it this way. This one the strip. In this strip, what is the pressure is on the strip? Okay, so we can write the pressure on the strip equal to, we know that pressure formula rho gh. In the previous lecture already we have discussed this one. You can see that lecture. So this pressure on the strip equal to P equal to rho gh. And what about the area? So area A on the strip equal to, we can write that is, because it is a small one, so we can write dA, and that one we can write what the width of this is the width. This is a plane surface. Okay, this is a plane surface. If you consider a small rectangle on behalf of this arbitrary shape, then this will be the shape, like front view of the rectangle. And if you see that rectangle side view, then only you can see one line will be visible. Okay, similarly this is a plane surface. Okay, now this area what I told, area we can say, we can take a small area dA, and that we can write B into, and what is the height is there, this one dh, that one we can write in terms of area. Similarly, next we'll go for the total force. Okay, next write down the total force on the surface, on the strip. Okay, so we know that pressure equal to force by area. So here the force what we can write, pressure into area. This is the common formula, simple formula we know previously also. So here the total force what we can write, so let write in df, a small strip, so that is P into, what about the area, that is dA. So we can write, we know the formula, we know the value of this P equal to rho gh, so I can mark there rho gh into dA. Okay, this is about the dA, total force on the small strip. And now this is about the small strip. Now if you want to calculate the total pressure force, okay, the total, let me write the total pressure force on the whole surface, the total surface. This is about on a small one. The total surface, total pressure force on the surface, if you want to write, then we can say on the surface equal to, we can just integrate this one, integrate df, and integration of rho gh, okay, dA. Now df, we know that integration, if you do again, let it keep f. So, and here the integration we can see rho gh is constant, we can take it to outside. So no, rho g we can keep it as a constant value, keep it outside of the integration, and h dA let keep inside the integration. Okay, what is the h dA? Now see, h is the distance, as I told you, the distance from the what, free surface to the strip, and dh is the this is the width of this, or sorry, we can say the height of this. Okay, the distance or the height of this small strip from this. Okay, so and dA equal to, actually here what, dA is the area. Okay, dA is the area of that. So now this one we can write the h into dA, the concept of this h into dA, that is nothing but the moment of the surface. Okay, the moment of surface area. This about the surface area. This is surface area. What is the moment? So this h into dA, we can write moment of the surface area of the strip. So that is HDA. So integration of HDA, that also you can write moment of whole surface area. So if you write, you do one thing. This is HDA, and similarly integration of HDA, if you write, then that will be called as the moment of surface whole area, whole surface. Okay, the same thing. Moment of surface area, surface of whole surface, the total surface of this object. Okay, so that one we can write in terms of if you are going to calculate consider this total whole surface, so you can write there A into H. Okay, so that one we can write area into the distance. This is nothing but area, and this is the distance from the center of gravity. Now we need to consider this on behalf of this whole surface. We can consider this A into H bar. Okay, so A into H bar, that is the distance from the center of gravity, because we are considering that whole surface, so that one we can write in this. So now in this place, in the integration HDA place, we can put this value. So we can write, now we'll get what F equal to rho g, and now on behalf of integration HDA, that is nothing but moment of whole surface area. So that one we can write A H bar. So this is the total force. This is the total force on the surface. Okay, this is one thing. Now the second part is of this. Second thing is we need to identify the center of pressure. The second part is center of pressure, and which is indicated by H star. And actually here we need to just consider the moment of this. This is the height, the distance from here. So what is the center of pressure on this point? Okay, what is the force exerted by this? Now for this we need to consider the moment of force. Okay, so what about the moment of force? What about the momentum force F about the free surface? You can write about the free surface. Now we need to consider the moment. So moment we can write a moment of force, or to calculate the moment we know that force into the distance, okay, or the height, how much is there. So that one we can write F into H star. Okay, F into H star, because this is the formula of moment. So what is the moment of this point? Okay, so how much force is applying here, and what is the distance covered from the free surface to this point? So that is nothing but F into H star. So in this previous equation we got the value of H here, F equal to rho g A H bar. So that one I can write F equal to rho g A H bar into H star. So this one we can give equation 2, and previously already what we got here, that one we can give equation 1. Now what will do? Momentum force dF, moment of force dF, okay, about the surface area, about the surface area, that would can write. Similarly, how much is there? df into h. Now see the diagram here. Now when I consider this point, the center of pressure here, the height was h star, and when I'm going to calculate for this on a small strip, how much height is there and what is the area of that. Okay, so that is height, how much height is there, what is the height of this, and what is the force, the small force acting on the df. So previously already we know that the value of df is rho g h, this one. Let me show you here. Yeah, rho g h dA. So you can write rho g h dA into h. Okay, so here h square will be there, so you can write rho g h square to dA. Okay, this one we can give another one equation. Okay, equation 3. Now the moment acting, we can write again one more point, the moment of force, the moment of force acting on the whole surface. Okay, this is individual what we have calculated, moment of force acting on the whole surface, what we can write about the free surface, about the free surface, we can write this one, that is integration of rho g h square dA. Okay, now similar thing we can write rho g, we will take it outside, integration of h square into dA. Okay, now this h square dA we can write again, h square dA is nothing but the moment of inertia, the moment of inertia of the strip, the moment of inertia of the strip area above the free surface, because everything we are considering from the free surface only. So this is the free surface, that is h square dA, moment of inertia of the strip, which is strip area above the free surface. Okay, now this one again, if you take the integration of this, similarly integration of the h square dA, that we can write, okay, that is the moment of inertia of the whole surface, mi of whole surface. Okay, whole surface area at the force surface on the liquid. Okay, that is, we can write, this is moment of inertia, we just can write I naught. So now what we'll do, on the value of this h square dA, this integration of this one, I can put the value of I naught. So what I'll get then finally here, I can write here that we can write rho g I naught, rho g I naught. See this value I just replaced with this I naught value, that is moment of inertia of the whole surface or whole area at the force surface of the liquid. Now this is another one equation, this is equation number 4. Okay, now what we'll do, we know that as per the parallel axis theorem, because see this one, if you consider this is one surface or this is one plane, another one is there. If you consider the parallel axis theorem for this, then we can write the moment of inertia I equal to I naught equal to, you know, that Ig plus AH bar square for the height of that. Okay, so this is the formula for that, and here we can write here this is the value of I naught as per the parallel axis theorem. You can write as per the parallel axis theorem. This is another one concept is there, just to keep in mind, as per this parallel axis theorem, this is the formula is there. Now this I naught value, what I got here, Ig plus AH bar square. Now we can put this value on this equation, then what will get here, that is we can write rho g in bracket Ig plus AH bar square. Okay, this is the equation. This is equation 5. Now we can do one thing. We can compare this equation and the previous equation, what we got here. Okay, now, because we need to find out the value of this H star at the center pressure, how much is there. So now compare this equation 2 and 5, we'll get now here rho g AH bar into H star, okay, equal to, you can write here rho g and here Ig plus H bar square. So now rho g will be cancelled and we'll keep H star one side. Okay, keep this H star one side and remaining part will take it to other side. That means Ig plus H bar square divided by this one H bar. Okay, H bar. So now split this one. So we'll get what finally, let me write here the final answer, that will be H star equal to, we can write Ig by AH bar, Ig by AH bar plus AH bar square by AH bar. That AH bar will cancel, only one area cancel, only this area will be cancelled, only H bar will be there, H bar. So this is the final equation. H star equal to Ig by AH bar plus AH bar is there. Okay, so this is the final equation of the center of pressure. So here what we can identify from this equation, and the center of pressure lies between the center of gravity of the vertical surface. The center of pressure lies in between the center of gravity of the plane surface. Okay, next one, we can say the distance from the center of pressure from the free surface of liquid is independent of the density of the liquid. Okay, because here we got this equation, and this is all about the concept of this hydrostatic forces on the vertical surfaces when submerged in the liquids, and the total pressure and the center of pressure. Okay, I hope you understand. If you are having any kind of query and doubt regarding this, you can give a comment on the comment box. Thank you all.